Well, I have a few minutes after 12, so I'm going to get started. Does anyone have any burning questions you need before we get started in the math today? I have one more coming on. Addison, if you would, please, on the chat, type your name in if you haven't already so we can get you for attendance. Thank you. Okay, I'm going to switch over to the smart board. This is week 3, level 1. Marco.
Hello.
Okay, we're good. Thank you. All right, let's go to the smart board. This week lesson, we are going to do a little reviewing from last week, but the new part is exponents and uses with numbers or expressions. I hope that many of you are already familiar with some of the things, and maybe not too much of it's new, but if you're not familiar with it, you need to be exposed to it. It's something that's very common using the exponents in math. The general topics underneath that we'll be covering on that today, adding new. They're used to save time, and we'll show you what I mean by that as well. That's why they're so commonly used. We're going to review the greatest common factor, do a review on that from last week, and the least common multiple. We should be okay on those, but we're going to review those this week. And then maybe we'll also do a little review on simplifying expressions. So the only new part is this about exponents. Well, let's get into the lesson for today before we do the classwork. Exponents, what I mean by they're used to save time, if I have x to the 4th, that means x times x times x times x. There's more to it than that, but that's the general idea. On your calculator, you have an x squared key and you have an x cubed key. After that, you have to use the x, and there's a little caret. If I wanted the 4th degree, I could do that. If you have your calculators handy, let's do that here for just a second so we know where those are on the calculator if we want them, okay? Let's do these 3 problems. 2 squared, 2 cubed, and 2 to the 4th power. Let's make sure we know how to do those on the calculator before we get started today. So, on your calculator, to find the key, everybody clear your calculators. If you have their handy, clear it. Should know how to do this, but not, let's learn. Put 2, and your square key is on the left side in the middle. And it should, when you do 2 squared, if you do it correctly on the calculator, it'll look exactly like this. And when you enter, all you have to do is the lower right-hand corner. It will tell you 2 times 2 is 4. Now, I would never need to do that on the calculator, but there would be harder problems that, yeah, that would be helpful. Let's do this. Let's make it look just like this on the calculator. There your calculator again, and put 2. The cube key is under your math key. The math key is under the alpha key. So under your alpha key, hit math. And number 3 is cubed. And when you do it, it should look just like this. And when you hit enter, it will say 8. 2 times 2 times 2 is 8. And the last one we want to practice before we get into some of these problems is this. And that is going to be 2. And then we're going to do the caret key. So clear your calculators and put 2. The caret key is on the right-hand side in the middle, under clear. So put caret and 4 and enter, and it will say 16. And then if you wanted a 5th power after a cube, you use the caret key all the time. So I hope you already knew that, but if not, there's a little instruction on how to use your calculator with numbers anyway. It's not too helpful with variables, but with numbers we can do that. Well, let's look at some exponent questions. Here's some that we should know. Let's start with numbers first. What is 4 to the 1st power? Say it to yourself. Yes, it's 4. Do it with or without a calculator. What's 4 to the 0 power though? What is that? It's 1. All numbers, doesn't matter what the number is, the 0 power is 1. The only exclusion is 0. That doesn't work with 0. And if you tried on the calculator, if you actually did this on the calculator, 4 caret 0, it would say 1. It's built into the calculator. Okay? Keeping with the number 4, what's 4 squared? Go ahead and say it. It is 16. 4 times 4. But what's 4 when you do negative exponents? You can do it with or without a calculator. It's flipped. It's still 16, but it is 1/16. Now, just a word about the calculator. If you're doing these on the calculator, 1/16 wouldn't say 1/16. It would say 0.0625. Your calculator's default decimal. All I have to do is hit my math key. Again, that's under the green alpha key. Hit math, fraction, enter, and it would say 1/16. So when we have negative exponents, it works the same, but it flips it. It takes the reciprocal. What is 4 to the 1/2? Fractions. Oh, have you ever done fractions as exponents? They are roots. In other words, really, this is the square root of 4. This tells me it's a square root. Well, the square root of 4 is 2. Could I do it on the calculator? Yes, but it's a little different. I would say 4 caret. And since I'm going to have to do more than one number, I would put in this 1 divided by 2. I'd use parentheses after the caret key. And it'll tell you 2. So fractions are roots. X squared. That means x times x. And I'm glad we don't have to write it out longhand. I'm glad that we can just say x squared. X to the minus 2, what would that be? It'd be 1 over x squared, okay? Or 1 over x times x in parentheses. Works the same with variables. A little different, but close to the same. What's x to the 0? Come on, say it to yourself. What's x to 0? It is 1. As long as x is not 0. It's true for all numbers except 0. What's x to the 1/2? What's x to the 1/2? Well, it's the square root of whatever x is. Are there any questions so far before we start doing some examples? Any questions about the general rules for exponents? I hope you've had them before, but if not, it's time we solve some problems with those. Any questions? Okay. Let's do some examples here before we go to the classwork. Usually with exponents, you can do a lot of different things, but primarily to start with, you're asked to do the binary operations. Add, subtract, and I put those both in the same color, they're similar. Multiply up different rules and divide their different rules as well. Let's look at some examples. Let's say we're going to add. When you add with exponents, the exponents must match each other. Do those match each other? Yes, they do. So I add as always. 4 plus 2 is 6. $6. 6 carrots. 6 chickens. 6 is something. Well, the something is x squared. Now, when I first saw this, I didn't quite believe that that was true. So I picked a number. I said, okay, I'm going to let x equal 2. I'm going to see if this really works. So I'm going 2 here. 2 times 2 is 4. So that's 4 times 4 plus 2 times 2 is 4 times 2. 16 plus 8 is 24. My answer was this. Well, let's put a 2 in there. 2 squared is 4. 6 times 4. Oh my goodness, it actually works. So when you add, the exponents must line up or you don't add. Same thing for subtraction. All of you do that problem right there. Do the subtraction. What would that answer be? And again, I hope this is review for you so far. But if not, you need to pick it up. Have your answer? Well, the exponents match with both cubes. $7 spend $3 is $4, but they're not dollars, they're x cubes, is what we would call the most practical answer. So, question about that. Okay, now let's talk about multiplying. When you multiply, in other words, we did some addition and subtraction. We did a couple examples there. Now, that's not all there is to it, but that's a start. Well, next, let's do some multiplication. When you multiply, the exponents do not have to match. You multiply numbers as usual. You don't have to do it first, but usually it's first. I know that 3 times 5 is 15. And then you add, well, that's odd, we're multiplying, but you add the exponents. X to the 5th. So the answer to that one in green is 15x to the 5th. So you got to remember, when you multiply, you add exponents. You add exponents. Different rules. What's that answer? Everybody write that answer down. You have it? It's 1 times 1, or 1. X to the add 7th. Okay? Also, before I go to division, I want you to notice on both of these problems there was no addition. In other words, if I had this addition within a multiplication, in other words, x squared plus 3 times x to the 4th, that's a different problem. The rules are slightly different than this. Or if I had x cubed plus 7 times x squared plus 4x minus 3, that's a different problem as well. Notice the addition and subtraction. It changes the rules slightly. Most of you already know how to do it. You do it with the distributive property, or call it FOIL, whatever you want. It's really called the distributive property. These today had no addition or subtraction within the multiplication. Let's do some simple division problems. Again, this division, there's not going to be any addition or subtraction. If there is, it's altogether different. When you divide, the rule is you subtract the exponents. And again, you see no addition or subtraction in this problem. So I would subtract 5 minus 2 is 3 over 1. Now, since the 1 is in the denominator, I would drop it and just say x cubed. And that works unless the problem would have looked something like this. X to the 4th plus x squared over x cubed. That's a different problem. You can't subtract there because there's addition in the problem. And we'll cover that a little later on. I hope you already know the difference. But here, there's no addition to subtract, so when you divide exponents, you subtract. Try this one on your own. Do this one. Everybody get that answer right there? What would that be if we simplified that division problem? If you get the first one that I circled, go ahead and do the second one that's on the board. If you get the first one, do the second one as well. Well, let's look at the first one that I circled. I look at the numbers separately. Again, there's no addition in the problem or subtraction. So I divide as normal. 2 divided by 8. Well, that is 1/4. 1/4. Then exponents. 2, there's an understood 1 there, is an x. So the answer is x over 2. X over 2. Now the reason those rules are the way they are, if you pick numbers, in other words, and say, oh, I don't believe that's true, okay? Okay, well, let's let x be some number. Let's let x be 4 and see if it's true. 4 squared is 16. Double 16 is 32. 4 times 8 is 32. So the original problem in blue, I get 32 over 32 or 1. On my answer in red, I have 4 over 4. Oh, 4 over 4 is 1 as well. And it wouldn't have mattered what number we picked. This always comes out to be the only correct way that you would state it. So the rules work with numbers. It's all based on add, subtract, multiply, and divide, what we learned in 3rd grade, 2nd grade. Okay, what about this one, an unboxing unit? Did you get an answer for it? If not, let's try it. Everybody try that one. What's the answer to that? A hint or a help, if you have parentheses and an exponent without addition, you multiply the exponents. If there's no addition or subtraction, which there's not here. You have an answer? Need more time? I'm going to have, when I rewrite this, there's no addition or subtraction here or here, so I can just multiply the exponents. I have 4, x to the 0, y to the 0, over 2, x to the 0, y to the 0. When anything in the 0 power, they're just a bunch of 1s, so I have 4 over 2. So my answer to that one is just 2. Now, I could have seen that right here. This is 0 power is 1. This is 0 power is 1. 4 over 2 is 2. Questions there? Questions? Marco.
Hello.
Thank you. No questions, okay? Let's do a little reviewing. Use order of operations. Simplify that with or without a calculator. I don't care which one you use. Simplify that expression. You have a calculator there and you want to use it, that's fine. I'll tell you though, if you have a calculator, you better use parentheses before you use that bar for division. Okay? Or you can do it without a calculator. Simplify that expression. What's a better name for it? Well, let's see if we agree on the answer using order of operations. I'll start in the numerator right here, and I multiply first. 7 times 0. Now that's not an exponent, so it's not 1. It's a multiplication problem. That's 0. 0 plus $36 is just $36. Work in the denominator. Order of operations, you do this first, division and multiplication. 0 divided by 8 is 0. $0 plus $4 is 4. I would expect to divide it out. 4 goes into 36. With or without a calculator? The answer is 9. Questions there? And with the calculator, you would have needed these red parentheses, or it would not work. It would not work. Okay, let's do, what else should be? Oh, least common multiple, greatest common factor. From last week, can you still do the greatest common factor? How about 68, x to the fourth, and 48, x cubed. Without me telling you anything, find the greatest common factor. See if you can still do that. What is that expression? See if you remember from doing it from last week. Do you have it? Do you have the largest factor that they have in common? Do you have that yet? Let's see if we can agree on an answer. To do that, I have to find out what they have in common, so I have to break them down. 68, 2 goes into 68 34 times. 2 goes into 34 17 times. So on the 68, it is 2 times 17 times x times x times x times x. 48. What's 48? I don't know, so I'm going to do the arithmetic on it. 2 goes into 48, 24. 2 goes into 24, 12. 2 goes into 12, 6. 2 goes into 6, 3. Now I want to see what they have in common. They both have a 2 in common. So the greatest common factor so far is 2. They both have another 2 in common. So now it's 4. No more numbers. They both have an x in common. They both have another x in common. They both have another x in common. So the greatest common factor is 4x cubed. That's the largest number that goes into both of these evenly. So it's the greatest common factor. On your own, without me telling you, finish the problem. What's the least common multiple or the lowest common denominator? That's where we use that. But what is the smallest number that these two will divide into? Least common multiple. Give that a shot. See if you remember. I have half the work done for you with the greatest common factor. When you find the least common multiple, the first thing you do is find the greatest common factor. Are you getting there? You have the greatest common factor yet? Well, to find that, the first thing you do is find the greatest common factor. Well, I already did that for you. We did it together. So it's 4x cubed. Then I take the leftovers. Here there's a 17x. Here there is a 12. And I multiply everything together. The variables, pretty easy. I have an x to the fourth. There's an understood one there. And the rule is when you're multiplying, you add the exponents. And let's see, 4 times 12 is 48. Times 17 is something. 816, I think. You might want to check my arithmetic. That means both this number and this number will divide into this number evenly. And it is the least or the smallest that they have in common. Well, that's a little review. Let's go to the classwork for today. Remember now, take good notes on the classwork, and you already have it finished. And the homework is just like it, so you'll have good notes as a guide for it. Okay. A calculator may be used. Please place your final answer on the bottom to receive full credit. What is this product? Now they tell me right up front, there's a product. And I know as long as there's no addition or subtraction in the problem, there's no addition or subtraction here, I add the exponents and multiply the numbers. So if I was doing this, I'd say 6 times 4 is 24. And if I add the exponents, 3 and 5, that's 8. And there's only one answer C. Answer C. I'll get that down. I'll give you a second to take some notes there. See what I did. All I did was multiply the numbers like I usually did. There's no difference in what I did here than what I did back in the 3rd grade. But the exponents, I added those. 3 plus 5. Everybody get the notes that you want. And if I was labeling these so I could follow them later, I'd say A, B, and C. That's the order I did them in. You don't have to do the numbers first. That's just the way I was taught. Questions on 1? Okay, let's go to 2. What is the greatest common factor? What is the greatest common factor? Give it your best shot. Go, and then we'll see if we agree. 60x to the 4th and 150x cubed. We just did one just like that. What is the greatest common factor? Go. Okay, let's see if we're going to answer them. My first step, step A, is I'll see what they have in common. And 60 is 2, 30, 2, 15, 3, 5. And then I have X, 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 X. Step B. 150. Oh my gosh, 150. It's 2, 75, 3, 25, 5, 5, and it is X, X, X. Step C, we'll take what they have in common. They both have a 2 in common. They both have a 3 in common. They both have a 5 in common. And they have 1, 2, 3, 1, 2, 3 X's. So my answer is 30 X cubed. And is there, yes, answer is A. So there it is, step by step, the greatest common factor. Questions there? You might have a question. Get the notes that you want on it before we start the next one. Everybody get the notes down if you want them. Okay, let's do number 3, which is the greatest common factor. You got to find it to get the least common multiple. The least common multiple. What would your step A be? Anybody tell me? You got your first step? Let's find the greatest common factor. So I would say 60 is 2 times 2, 30, 15, 3, and 5. And I do it with this method here, 60, 2 goes in 30, 2 goes in 15, 3 goes in 5. Those are the prime factors of 60. I do the same thing for 150. It's 2, 3, 5, 5. So step A would just be running the prime factors. Step B, I'd find the greatest common factor. Even though it said find the least common multiple, you've got to find this first. What do they have in common? They have a 2 in common. They have a 3 in common. They have a 5 in common. So the greatest common factor is 30. Step C, I take the greatest common factor, which is 30, and multiply by leftovers. Up here, there's a 2. And down here, there's a 5. 300, and there is an answer. C is the greatest common factor. In other words, what by definition it means 60 would go into 300 evenly, 150 would go into 300 evenly, and there's not a least or smaller one that would do that. Okay, I hope you have those notes. Any questions? Any questions about number 3? Well, 4, do 4, simplify that expression either with or without a calculator. There's a 1 missing there. That should be a 1. Pardon me, that is not correct. I want right here, I don't know why it's not there, but there should be a 3 there. a 3. Go ahead and give it a try, either with or without a calculator. Well, the first step I did was right here. I did the numerator. 48, the 0, you have to multiply first. 0 times 16 is 0, so the top of the numerator is 48. My second step, B, was right here. 3 times 4 is 12, so $24 minus $12 is 12. C, the last thing I did was divide out. 12 goes from the 48 4 times. Again, I'll remind you, if you use the calculator, you need to put parentheses here and here. Questions on that one? Questions on number 4? Let's go to the next sheet. Simplify, okay? Here's how I do this in step by step. I do A first. 9 to the 0 plus 9 to the negative 1 plus 9 to the 1/2. 9 to the 0 is 1 plus 9 to the minus 1 is 1/9. Square root, that 1/2 is the square root of 9 is 3. So if I add all these up, I get 1. See, they're all adding. I get 1 plus 3 is 4 and 1/9. And this has to be the answer. It's the only one that makes sense. If I wasn't sure about that, I would say, if I wanted to check if that was right on the calculator, I would say 1 divided by 9 equals, and would tell me what that is, and then I would say plus 4 equals on the calculator. And I bet it's this. I bet it's 4 point, and that bar over it means it's repeating 1. So the answer is D, 4 and 1/9, or repeating 1. Questions there? Questions there? Number 6. Simplify that one. Oh, wait a minute. This to the 0, all is 1 and 1. It ends up being 4 over 2. What's the answer? Answer is just 2. When you see to the 0 power and everything gets it, it's just some number to the 0 power. It has to be 1 and 1. So that made it a lot easier because of the 0 power. Answers 2. And the last example for today on classwork. Simplify. Take about 30 seconds and see if you can do that one. 2 to the minus 1 times 2 to the 0. What is that? My step A, 2 to the minus 1 equals 1/2, and 2 to the 0 equals 1. And just state what they are. Step B, I have 1/2 times 1. That equals 1/2. And that is 0.5, and the answer is A. Any questions? Everybody have the notes that you want? Any questions about any of the things that we did today? Anybody have any questions? Homework is very similar. The new part are exponents. Now, next week, there won't be anything new. We'll spend the whole time. We're halfway through the course. We'll have a lot of review problems, though. But still, you need to be here and look at it. Practice may not make perfect, but it gives you a chance. Carissa, you have anything you need to add? Beth, anything you need to say? John, what about your end? You have any administrative things you want them to know?
Well, just make sure you all turn in your homework. If you have any questions about what you're missing or haven't gotten turned into us, please come to study hall here in a little bit. We can help you out.
Any last comments? Well, I'll see y'all next week. Please try to do the homework lesson within 24 hours while it's fresh and while you have notes. Need help? See Carissa, and I'll see you next Thursday when we review. All of you have a good week. Bye-bye.